Hello everybody, this is Mr. Folly, and as long as all of these things look, hopefully this podcast won't take too long to do. These are the problems we're going to eventually do in the chapter, so don't worry about them right now. I just left them from basically the last slide. We're going to go over reactions, electrolytes, which has to do with the lab that we did before, double replacement, acid-base reactions, excess concentrated reactions, carbonate reactions, synthesis, and decomposition. I'm basically going to do 1 to 2 of these, and we're going to practice a ton of them. The reactions come in swarms, so this might be one we're going to watch a couple of times. Basically, for reactions, like dissolves like. There are key substances that you should really know. Like dissolves like, but if you know these things, then you should be fine. Like dissolves like means polar dissolves polar, and nonpolar dissolves nonpolar. And I'm just going to tell you what these things are. Water is polar, gasoline is nonpolar, benzene is nonpolar, methane is nonpolar, alcohols are polar. And the easiest way to check for polar versus nonpolar is nonpolar things almost always have C and H and nothing else. And that's one of the quick checks. That's true for gasoline, that's true for benzene, that's true for methane for being nonpolar, and that's a quick check. It's not a 100% true case, but it's pretty good. Net ionic equations in AP, most reactions happen in aqueous solution. And that means we're going to use net ionic equations, and I'll show you how to do that in a second. The sign of a chemical change is a precipitate forming or a gas. Rarely you have just a color change, but we need to know our aqueous color. So our sign for a chemical change might be that something changes colors. That was one of the test questions. You had Cr plus 3 plus aluminum turned into aluminum plus 3 plus Cr. Cr plus 3 is colored. Aluminum plus 3 is not colored, so a color change would have been one of the signs, as well as aluminum dissolving and chromium forming or precipitating out. So let's look at a bunch of these. Aqueous is always going to mean ions in this class. So NaCl means not NaCl together, but Na positive and Cl negative. K2S aqueous, sorry I was lazy with my subscripts and superscripts, gives me K positive plus S negative 2. And really, if I were to balance it, it would be 2K positive. Notice 2Ks on the left, 2Ks on the right, but also notice 2 positives, 2 negatives. The charges will also balance. Barium nitrate, Ba plus 2 nitrates. The one-time aqueous does not mean ions. It would be weak acids and bases, which in lab you figured out what your weak acids and bases were. But the strong acids and bases, it's easier to learn the strong acids than all the weak acids. The weak acids are basically everything else. But your strong acids are nitric, sulfuric, perchloric, and then HCl, HI, HBr, 1, 2, 3, 4, 6. Oh, I think I'm missing one. I got my nitrogen, my sulfur 1, my chlorine 1, and then 1, 2, 3. So I should have 6. Oh, I do have 6. Okay. So those are your strong acids. Your strong bases, these are strong. Your strong bases are group 1 and 2 hydroxide. And we learned in class today that strong things ionize 100%, and weak things are less than 100%. It's also worth noting I'll change my color again, the weak bases almost always have something, blah, attached to an NH2. So if I had CH, blah, 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 C, CH, 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 NH2, that's probably going to be a weak base. Stability rules are the next thing we're going to look at here, and you got a copy of those in class today. It's very important that you know the first 3 in the core of your soul. They're the most common ones. If you know what's soluble, you can usually figure out what's not. Nitrates, group 1, that's column 1, and ammonium are always soluble. Acetates are soluble except mercury. Most chlorides are soluble. Exceptions are silver chloride, lead chloride, and mercury. Silver, lead, and mercury are exceptions a ton. So you have this sheet. You're going to work with it so much you're going to memorize it, refer to it a ton, and that's about it. So let's do a bunch of them. Electrolytes. We learned this in class today with our lab. Ions conduct electricity. Soluble salts make ions. Strong salt make ions. Strong bases make ions. Weak acids and bases are poor electrolytes because they make few ions. See our lab. Alcohols are also poor electrolytes. Sugars are non-electrolytes because there are no ions in moleculars. Anytime you have to explain why something conducts electricity or not, you need to say electricity is a flow of ions. And then your answer has to address whether or not something has ions and whether or not your ions can flow. Okay? And we'll get into that a little bit more in later chapters. Double replacement. In double replacement, pretty much everything is aqueous unless otherwise stated. And it says that in the directions. The way that I like to do is I find the precipitate and work backwards. So I'm going to be quoting these solubility rules like they're gospel, except for I can't really quote gospel. And you want to watch for weak acids and bases and the word solid or gas. So let's do a bunch of examples. We'll do a bunch of examples. Here we go. Sodium chloride reacts with silver nitrate. So some of the things that I want to go over first about solubility rules is if something is always soluble, I say I don't believe in it. So the things that were always soluble are group 1 and nitrates. And since they're always soluble, I say I don't believe in them. So if this was atomic sol, you'd write NaCl plus AgNO3 would yield AgCl plus NaNO3. And you'd be so happy with yourself as you looked at some cheesy chart that said AgCl was solid. But really, I would think if you were in my class, you wouldn't even go that far, because the first thing you know is an ion. However, aqueous means ions. Na positive plus Cl negative plus Ag positive plus NO3 negative yields AgCl is a solid, so I would not write that as an ion, plus Na positive plus NO3 negative. And like I said before, sodium is always going to be soluble, and notice how they'll cancel out. Nitrate is always going to be soluble, so it's always going to cancel out. And if I were writing the sodium, and I would laugh at nitrate, because they are always soluble, so I don't believe in them. So I would simply say Cl plus Ag positive yields AgCl. It really helps. Sodium, hydroxide reacts with iron to acetate. I'm going to laugh at acetate. It's almost except for mercury, which is so toxic we never use it. So what I have here is hydroxide plus Fe plus 2 yields. The other nice thing about AP chemistry is when it gives you a reaction, there's no such thing as a no reaction. So you have to know that this is your product. Even if you don't know your solubility rules, oxides are insoluble or precipitate with above, unless they meet the above rules. Now, the other thing I want to talk about, solubility rules, which I skipped, was slightly soluble. And slightly soluble, if you think about that, it's like, I don't really know what that means. Soluble, whatever, soluble. If I said, oh, I see you Friday night, you're slightly attractive, that means mostly not attractive. Right? So if something is slightly soluble, that means it's mostly not soluble, which really means it is insoluble. Okay? Let's do a couple more. See what we come on, change. Potassium sulfide. Potassium's in group 1. Reacts with strontium chloride. Sulfide is S negative 2. This is a group 2, so I can't get rid of it. This is chloride, I can't get rid of it. S negative 2 plus SO2 plus Cl negative yields. Now this is the only thing that's new, so it's got to connect with something else. So it's got to be SRS, charges cancel, and then it would be plus chlorine, or chloride, pardon me. And since it's the same thing on both sides, I'd get rid of it, and I would have S negative 2 yields SRS. And there has to be a reaction, so that's good. But you should also know in your solubility rules, most sulfides are insoluble, unless it's group 1. Weak acids and bases stay together as reactants, so that means just don't ionize them as reactants. They still react, but they don't do anything else. Ammonia, NH3, take it easy. Reacts with hydrofluoric acid. So ammonia is a weak base. Hydrofluoric acid is a weak acid, so I don't ionize those. Now, acids give up H's, which you barely need to know, but it's good to know here. And if you're trying to make something that looks familiar, H is going to hook up over here, and you're going to get NH4. Now remember, H is really H positive, so it's NH4 positive plus F negative. And then you have the question, okay, so is that a precipitate? Ammonium was one of the things that's always soluble. Now looking at this, it looks like nothing happened. But what happened was I went from no charge to no charge to a charge thing and another charge thing. So something definitely happened. So we've changed those things around. So there's your reaction. Not to have a precipitate, but there's a double that doesn't have a precipitate. It's not even really a replacement. Phosphoric acid reacts with excess calcium hydroxide. Phosphoric acid comes from phosphate, H3PO4. Reacts with excess calcium hydroxide. Calcium hydroxide is a strong base, so I'm going to go ahead and ionize it. Now, if it says excess calcium hydroxide, that means I've got tons of this and tons of this. But I want to try and figure out what it would react with. Will hydroxide react with hydrogen? That'll make water. Is water a new product? Yes, because water is not on the left. So looking at this, I would think, okay, so I'm going to get HOH plus HPO4 negative plus Ca plus 2. But because there's excess calcium hydroxide, that means I have tons of this. So my other hydroxide will react with not one H, but all of them. So H3PO4 plus Ca plus 2 plus OH negative gives me 3 H2Os plus phosphate plus calcium. And then I believe calcium phosphate actually is a precipitate because most phosphates are insoluble. So Ca3PO4 taken twice. Okay. Same question, yet not the same question. Equal volume, equal molar phosphoric acid reacts with calcium hydroxide. So I have phosphoric acid again, H3PO4, with calcium hydroxide. Now because it's equal volume, equal molar, whoops, I meant to ionize that. Then equal volume, equal molar means I'm going to get 3 acids and 2 hydroxides. So I'm going to get 2 H2Os, whoops, plus HPO4 negative plus Ca plus 2. And honestly, we don't have a solubility rule for this. And if you wrote this either as a precipitate or an ion, AP counts it. Surprisingly, they're a little nice on some things. Equal volume, equal molar means use some, not all, H's. Excess means use all. And I said H's, but it could be H's or OH's. And an OH, I'm calling them OH's. They're hydroxides, of course. And H's are the acidic part, and OH's are the basic part. Move on, I hope. Complex ions, Lewis acids, bases. This is one where you just memorize it. It makes no sense. And even the time get crazy. Complex ions form when the words excess concentrated, or sometimes just concentrated. Double the charge of the transition metal. You need a transition metal. So you're going to double the charge of the transition metal, which makes no sense until I write it out. Excess ammonia, ammonia is NH3, is added to silver chloride, plus AgCl. Silver is a D-block metal. So whatever you add to it, you're going to double the charge of the transition metal. So I'm going to get AgNH3, believe it or not. The charge on silver is plus 1. So I'm going to put 2 AgNH3 taken twice, plus what's left over? Cl negative. What? Huh? Well, that made no sense, but that's all right, because right now we're going to, again, whatever you're adding that's excess, you would double the charge, recalculate the charge, which I forgot to do, Ag is +1, NH3 is 0, AgNH3 positive plus Cl negative. Notice how the charges balance as well as the numbers. Don't get it yet? That's why we're doing more. Excess concentrated potassium hydroxide is added to copper 2 hydroxide. So I've got potassium hydroxide is added to copper 2 hydroxide. So I have OH negative plus CuOH taken twice. Excess concentrated, so my copper's charge is copper 2. So I'm going to have CuOH taken 4 times. Now I need to recalculate the charge. 4 OHs equal -4. Cu plus 2 is +2. So my charge on this is going to be -2. I'm left with a complex ion. Those we have to do them before they become your happy place. Carbonates, this is the rule. Carbonates decompose into carbon dioxide and metal oxide. Barium carbonate is strongly heated. If something is strongly heated, all it can do is fall apart, basically. So carbonate, so BaCO3, we should say solid. Solid barium carbonate is strongly heated. It's going to decompose into carbon dioxide, CO2, and metal oxides, BaO. Okay. By the way, the reverse reaction, I like to say when you have gases, and carbon dioxide obviously is a gas, in the reverse reaction, whenever you add a gas, I like to say there's a smoosh rule. If you add a gas to something, you just smush it together. So if I had BaO plus CO2, that would smush together to make BaCO3. And we'll see that here in a little bit too. Strontium carbonate decomposes. SrCO3, I've crisscrossed them in my head. And I get carbon dioxide and the metal oxide, SrO. And I use SrO because strontium is +2, oxygen is -2, so they balance. Of course, I wouldn't leave those charges hanging on there. Yeah. Metal oxides with carbon dioxide makes carbonates. This is my smoosh. Solid sodium oxide heated in the presence of carbon dioxide gas. So I'm looking at a gas here. Solid sodium oxide, Na, periodic table says +1, oxide, -2. So I have Na2O is heated in the presence of CO2. It's a gas. If I have a gas and I'm not quite sure what to do, or if I am sure what to do, I smush it. Na2CO3. Love the smoosh rule. That is a Mr. Folly special. You won't get that anywhere else. So, shh, keep it a secret. Hot carbon dioxide passes over magnesium oxide. Magnesium oxide, magnesium's +2, oxygen's -2. Carbon dioxide, CO2, smoosh away, MgCO3. And why people remember smoosh? Because it's a funny word in Indiana. Potassium, and then we've got some different synthesis things you have to familiarize yourself with. Potassium oxide is dropped into warm water. This is actually called it's a metal oxide. Oh, it's just one word though. Metal oxide, which is really a base anhydride. And remember how I said bases typically have OHs in it? Anhydride means it's a base without water. So look, if I have K2O plus H2O, if I know this is a base anhydride, I'm going to make the base out of it, KOH, right? And then I have to balance it. So I need 2 of these, and that balances it right there. Problem with this, I put it in warm water. This is a strong base. I need to ionize it. So this would say solid. Potassium oxide is dropped into warm water, so I have K2O plus H2O yields 2K positive plus OH, 2 OH negatives. And that's the ionic thing that we're going to forget for a while until we are sick and tired of it. Sulfur dioxide gas is bubbled through hot water. This is a non-metal oxide. I forgot my N. Non-metal oxide, which is called an acid anhydride. But these are nice because these you get to smoosh too. Because non-metal oxides are almost always gases. Metal oxides are almost always solids. Ionic bonds are strong. And non-metal oxides have weaker attraction, so they're gases. So I have SO2 is bubbled through hot water. H2O. If I know it's an acid anhydride, I'm going to make an acid out of it, which would be H2SO3, and make sure it balances. Whenever you smush the things, if you want to make sure that it's something you can be happy with, you want to make sure that it will balance. 1 S, 2 H's, 3 O's, 3 O's, and you're right. Very rarely do you write something that balances that will need full credit, as long as you ionize correctly. That's long. Decomposition. Metal hydroxide makes metal oxide plus water. Non-metal oxide makes non-metal oxide and water. This is the opposite of anhydrides. So if you know your anhydride thingamabobs, you can do this switch. Non-binary salt. Non-binary salt would be something like Na2CO3. That's my carbonate rule. Metal oxide plus carbon dioxide. Now, if I had Na2CO3, I know what to do. I'm a brilliant man. If I have Na2SO3, it wouldn't be CO2 it would get. It would be your most common oxide of sulfur, which would be SO2. And what you'll hear me say a million times, one of the trivia things for SO2 is SO2 smells like rotten eggs. So SO2 smells like rotten eggs, which is very bad. Metallic chlorates make metallic chlorides, O3. And that's going to make your metallic chloride plus oxygen. That's a brand spanking new one. Electrolysis decomposes compounds into elements, water, and dilute acids. Okay, that one we're just going to see a whole bunch more. Hydrogen peroxide, this is just a memorized one. Boo. But just hydrogen peroxide does not make, hydrogen peroxide is H2O2, does not equal hydrogen plus oxygen. It does not. No. 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 Carbonates, we already did. Ammonium carbonate, again it's a carbonate, gives us CO2 like we'd expect, and then instead of getting the nonmetal oxide with ammonium, anytime you have NH4, a lot of times that turns into NH3. And if you need an extra oxygen, you see water popping up in different places. You'll learn that whenever you see ammonium, NH3, ammonium is NH4 positive, NH3 will pop up, and you can pretty much add water wherever it makes you happy. A lot of times you'll see this, you kind of get a feel for it. So, hydrolysis, a compound reacting with water. Watch for soluble salts that contain anions of weak acids. The anions of a conjugate base. I don't understand. Let me show you. Calcium fluoride, CaF2, dissolves in water, plus H2O. So basically, instead of thinking of it as H2O, remember it's H positive and OH negative. Will H react with F? Only if it's weak. Oh, it is HF. Okay, so that actually forms. Will OH react with calcium? We're going to say no because that's strong. So that means it'll leave me with Ca positive, 2, plus OH negative. And make sure you balance these things. Solid strontium nitrite, SrNO3 taken twice, is dropped into warm water, plus H, and write as HOH so I can see it better this time. So will H react with, oops, it's nitrite. Will H react with NO2? Only if it's a weak acid. HNO2 is weak. HNO3 is strong. OH react with strontium? No, because that's a strong base. Sr plus 2 plus OH negative. Again, how do I know my weaks and my strongs? I memorize strong acid. And my strong bases, strong bases are group 1 and 2 hydroxides. Ton of stuff in this. You might want to make sure you review your notes for the different types of reactions. Pod quiz won't be terribly evil for this one. Some of the reactions are probably the exact same ones in your notes, so make sure that you have good notes. If you need to go back and write down those reactions instead of just the rules, you might want to do that to be sure, but you definitely have those rules in your notes. And we're out of here in the wonderfully short time of under 20 minutes, if I can hurry up and get this in here. So have a wonderful evening. Your parents have just experienced, oh no, it's South Campus open house night. So be good. And go to bed now and tell your parents because they're going to pay for your college. Bye.